My name is Nicolas. I'm working on Android Studio and on ConstraintLayout and MotionLayout.
Hi, I'm John Hoford. I am also on ConstraintLayout and MotionLayout and the design surface.
So today we're going to talk about ConstraintLayout 2.0, what's coming, what's already there, and specifically about MotionLayout, which is a part of ConstraintLayout 2.0. So very quickly, how many of you are actually using ConstraintLayout today? Pretty much everyone. Good. Hopefully I'll still teach you a couple of things. And how many of you have looked at MotionLayout? Much less. Great. So you are in the right talk. Okay, so let me quickly run through the constraints in ConstraintLayout, which should be pretty familiar for most of you. So typically, what we do is we want to set up relations between widgets. It's a little bit like relative layout from that perspective. And we do that by creating a constraint on the design surface and Android Studio. You may not be aware, but the inspector that's modelized on the right here allows you to create a constraint by essentially casting array, and whatever it finds, it's going to connect to. So if I do that, it's going to connect to the parent here, to the top. I can do the same on the left. And that basically makes sure that the button, this text view here is correctly positioned. So that's great. Of course, you can change the size, the margin, and you can make that everything to 0 if you want. So that's how you can control the position. And that's the basic type of constraint that we do support. From that perspective, it's very similar to relative layout. Where things get more interesting is centering. So if you create an opposite constraint, so here I have a constraint on the left and a constraint on the right, the result is basically to center the widget. And of course, it works both for the horizontal axis as well as for the vertical axis. One really powerful feature that kind of help creating more flexible more reactive user interfaces is bias. So yes, you can center, but you can actually center more on one side than the other, essentially. And of course, this works as well on the horizontal axis. The other type of constraint we support are dimension constraints. So you got the typical wrap content. We ask the widget, please measure yourself. But we can set a specific dimension, depending on what you want to do. You can also set match constraint, which is a specific type of constraint. Essentially, that says, you know what? I don't know my size. I'll let you do. I'll let you set whatever dimension you think is right. And typically, if you do nothing, that simply is going to stretch the widget to match the targets that you set up. All right, and go back to wrap content. One thing that you may not, actually, yeah. So we can do the same thing with different widgets. So this one is created as relative to that text view. And we can create a constraint on the right. And we've got this basic behavior. If I connect the left constraint, you'll see that it's centered. So that's an important thing with centering. It works on everything. Whatever you constrain to, it will center it. So it's going to center on the parent. If you connect to the parent, it's going to center on a different widget, like this example. It can even center on the same anchor. So by using match constraint, we can do more than simply spreading around. A common example, but there is actually more if you look at the documentation, but a common one is setting a ratio. And you can all do that from Android Studio directly in the design surface. And again, the centering works equally well, even if you connect to the same anchor. So that's something not a lot of people would realize, but it's meant for that. So another type of constraint that we support in ConstraintLayout, we introduced it in the 1.2, 1.1 release. It's chain, and chain allows you essentially to create a group-like behavior on multiple widgets. The typical things with ConstraintLayout is that we try to be flat, to not introduce hierarchy, and chain allows you to bring a lot more interesting behavior that is more group-related. The typical things is the behavior is going to be spread. So here I have 3 widgets, and they're going to basically share equally the space. There's also spread inside, where we chop off the ends, and packed, which is essentially looking at it as everything grouped together. What's nice here is that the bias rules that I talked to you about with the normal centering also work with a chain group. And another important aspect of constraint layout that we introduced from the get-go, in fact, is the idea that we can have objects that are helpers objects, that are here not to be displaying something on your screen, but more to help you set up your layout. So a common one is guideline. So you can see this type of typical dialog screen with text views and widgets. I can create a vertical guideline, and I can basically constrain those elements to that guideline. Now, what's nice is that I can then move the guideline wherever I want, and everything is going to follow up. So we introduced in 1.1 a new concept called barrier, which is kind of related to guideline. And it's when you got this type of issue, right? You got your beautiful dialogue, and suddenly you internationalize it. And suddenly, everything is messed up. So how do you fix that? Well, you could try to constrain the text field to that text view, and that looks good. Not quite. If the first text view on top, changes sizes, you don't quite adapt correctly. So that's not the right solution. Barrier allows you to fix that. You create a barrier. Barrier appears. You can then, in Android Studio, using the component tree, add elements to that barrier. So I'm selecting those two elements, moving them onto barrier, and now the barrier is constrained to those elements. And by default, it's constrained to the left side, but you can constrain it to the end. And then it's just a matter of applying the constraint to the barrier rather than to the separate element. And that way, when things change, they correctly move. So that was a bit fast, sorry. So in Constraint Layout 2.0, upcoming Alpha 3, we're going to have more helpers objects like that. We have a linear helper that's kind of doing stuff that you would normally do with linear layout. We have a kind of flexbox-like helper that you can see on the right, and also a table helper. So the idea here is that if we can keep stuff as helpers, the actual view hierarchy is still flat, which, as we'll see in the rest of this talk, has really nice properties for animation.
So one of the things that I wanted to talk about is sort of our efforts with the design surface. Essentially, we are designing we're putting a lot of effort into making this an easy-to-use system for you to quickly create constraints and quickly create constraint layout and motion layout. So a quick kind of overview of it. You have a component tree and a palette on the left, on your left, design surface, and you have the attributes panel on the right. Now, when you select objects, you can use the attributes panel there and quickly create constraints by sort of casting rays. You can change the margins on them. You have a right-click menu that you can easily access. You can actually access the right menu on the component tree. So anything you can do normally with the right-click menu, you can do it right there, especially when your layouts get very busy. And in this particular case, I'm actually making a very complex constraint between two objects. Now, let's kind of just go through a little bit of how to use it. The simple one is you can just simply click on an anchor, those circles, and drag it off to connect to another object. It's pretty straightforward. You can use a different trick when it gets really close. Now, if you drag to the middle, anywhere on the surface that is not an anchor, it will actually give you a little tiny pop-up that says, oh, what is which one do you want to connect to? That's also very useful if you have stacked views. So if you drag here, it sort of casts a ray through and sees what it's above and allows you to connect to all the appropriate sides of each of the views. So another one that sometimes gets a little confusing for people is how to make a baseline connection where you actually constrain the baseline of two views. And we have a little tiny affordance to allow you to do that. Now, in this case, I'm just going to show you, you can simply make the center constraints by just dragging the lines between the two of them. Here, I'll demonstrate creating a chain. Select all the objects you want in the chain, and you can just simply, under chains, create a chain. But there are a lot of tricks that can be done. If you put it directly over, the menu will appear that says Insert into Chain. You can also rearrange the order of the chain by simply selecting one of the items in a chain, and there's actually organizational elements. So you see, we have a lot of very powerful right-click menu things in here that can be very easy to use to quickly set up a set of constraints. In this particular case, I'll sort of lay out the top 3 buttons fairly quickly for you. I create a chain. I select them and say align the tops of them. And then I make the final constraint to the top. Now all 3 buttons are properly constrained.
Okay, so hopefully we were not too long, and hopefully there were still some tidbits of information that you did not know, because that seemed to be a very well-versed room. Some of those elements are stuff we actually added in Android Studio 3.3. So if you haven't essentially played with the design surface in a while, please check it out. It's kind of like a continuous improvement for us. Okay, so let's talk a little bit about motion design. Why? So I'm not going to go into why you want motion. I think you should all be aware if you followed material design. The idea with motion is really to bring, it's not just for your application to be pretty, it's more to bring an extra layer of information. So you can use motion to kind of help the user decipher what the application is doing. And that's a very powerful concept. So if you've been attending droidcon SF last year, we gave a talk about how to take advantage of constraint layout to do animations. And one reason is because constraint layout has this really powerful concept where all those constraints we've been talking about, you regroup them and put them into an object we call a constraint set. That's a very nice thing because you can then manipulate things. You can manipulate those constraint sets, you can keep a bunch of them together, and you can replace the current set of constraints with one you just kept around, which is fantastic for animation because it's very easy to create one state and then switch to a different state for your layout. So this is an example of something we showed you last year, in fact, and you can see it's like your typical or collapsible toolbar thing. And there's a couple of interesting things there. One, it's actually relatively easy to do with constraint layout. As I said, you can create one set of constraints for the start state where the toolbar is big, and another set of constraints for when the toolbar is small. The thing you may not have noticed here is that, as often in computer graphics, we cheated it heavily. It looks like the animation is following and tracking your finger, with coordinator layout here. It's not quite doing that. What it's doing instead is following your finger, and after a specific threshold, we switch to the end constraint set, and we are just animating things ourselves. That meant that we needed quite a bit of code to do this somewhat simple screen. And, well, we didn't really like that. So we kind of want to get rid of all of that, right? No code is, in that situation, much better. And we are trying to build, essentially, a way for you to declare the motion so that we can take care of executing it in a nice way. And that's essentially what we've been working on this past year with Constraint Layout 2 and MotionLayout. So the way you can think about it is that you have one side which is just the framework API that do animations, and those are actually super powerful, right? You can do pretty much everything you want. They are very complete. Of course, you do need to do code, which goes back to our earlier point. So what we're building is a layer of, declarative layer for motion and animation that's specified in XML and that we can execute. And we execute that into a motion engine. On top of this, we're also building kind of a partner motion editor, a graphical editor in Android Studio that currently looks like that. So we are still working on it. We did a sneak preview at Google I/O on that. It's not quite available yet because we kind of want to make it read right. But hopefully it will appear, not too, far ahead version of Android Studio. So another aspect we have in ConstraintLayout 2 is this idea of helpers. And those are the things I presented earlier with barriers and guidelines and things like that. But in terms of what to do with motion, you can still use the same concept. And in ConstraintLayout 2, we actually made that class public. So you can create your own helpers object and use them. So here is what you could do. So yeah, that's what I'm saying. You can basically take it to encapsulate behaviors and reuse them. So here is a common example with a circular reveal animation, which I'm sure a lot of you have used already. And this is what it would look like in code. And you notice a couple of things here. We are not reinventing this animation. We are just using the Android framework support for it. What we did is we put this code into a helper, and that's actually all the code you'll need into that helper. What's nice is that then you can just reference this helper in your code the same way you would specify a barrier or a guideline, and that's it. So you can think about helpers as a tool for you in your toolbox to, basically take a bunch of behavior animation in that case and reuse them easily. So that's, broadly speaking, that's kind of our plan as the Android Studio and Android team on what to do to help you with motion. So we've got the helpers on one end that sit on top of the current very powerful animation API. We've got the motion editor working on this declarative XML and with this motion engine. So if we look back a little closer on the motion engine, that's what we call MotionLayout. Oh, actually, so let me quickly go an overview on MotionLayout. So essentially, MotionLayout is a subclass of ConstraintLayout, which is why we've been talking about ConstraintLayout so far, because if you do need to know ConstraintLayout, it's a view group. That means that there is some animation, some type of animation you may not be able to do with MotionLayout, but we do think that a large segment of the animation space can be done this way. Again, it's declarative. The idea is that you specify the motion, and you can think about it as a little mix between layout transition, property animation, coordinator layout a little. So there's all those aspects, but coming to you in a single package. The general concept, you have at the very least two states, a start state and an end state, and you want to transition between those two. Where we do things a little differently is that we added new concepts, or that may be concept that you know from other animation things, but where we do want to transition between those two states, but with a modifier. And those modifiers are called keyframes, and you can put them at any point in time during the animation, and they control, as you will see, a lot of things. So, to summarize, with MotionLayout, we have something that is like supporting this declarative motion specification. It's really great at doing this kind of fine-tuned, handcrafted motion interaction. I call it like bespoke motion. And specifically, we have a lot of really rich support for touch-driven animation and motion. So what I mean by custom animation is this kind of things, where to do that, in code, of course it's doable, but it would take you a while. While here with MotionLayout, it took a few minutes. And this is actually what it looks like if you visualize the path. You can see it's a relatively complex motion. Another thing that is great at, as I mentioned, is dealing with touch event. And what you'll see is that depending on the speed or the type of gesture that I'm doing on the phone, that view is going to be moving in a specific way. So it's not just a linear motion. It's not just tracking your finger. It also is going to take in account velocity and acceleration in order to produce a very, very natural motion. So how to use it? Because is it another one of those things where you have to throw everything away and restart from scratch? No. What we're trying to build is something that you can use today in your application. You don't have to reinvent the wheel. So if you want to use a collapsible toolbar, instead of doing it the current way, you could use a MotionLayout. And this is actually really trivial to do. So in that case, you don't rewrite your coordinator layout, you just replace the toolbar itself, but then you got all the expressivity and power of MotionLayout. And there will be a URL later on, but all of those examples are actually on GitHub, so you're more than welcome to go and check it out. And same thing, right? If we have a drawer layout, you can, instead of using the menu class, you could roll your own and do whatever crazy animation you want. It is really easy. Same thing, if you want to integrate it into a view pager, it's, again, very simple to plug in. And John will follow with a deeper dive on the features.
Yeah, so let's just kind of get into a little bit of how little pieces of it will work and sort of like help you bring it all together. So the first thing for a lot of animation effects you want to do is an OnSwipe, which is where you want to control it with a finger gesture. This also applies if you're like trying to build something like a coordinator layout type interaction, which is sort of a swipe of text. Now, the first thing to realize is you will add to the internal of the XML, you'll be adding an OnSwipe, and you're specifying the drag direction, the widget that is you can think of it as the anchor point for your swipe gesture, where the object that you will virtually move, and also the side of the object that you're going to virtually move. So with the drag direction, you can be up, down, left, right, left and right. The anchor is just a view, and the sides are top, bottom, left, right. Now, if you create an animation, the whole interaction will just move with your finger, but notice your finger will be ignoring the fact that it's moving horizontally. The swipe is just playing the animation between these two motions. So let's take a look at what I mean by the anchor side. If I'm dragging, you see my finger highlighted there. If I'm dragging, what's happening here is it's actually using the distance between that side and my finger and trying to keep that constant. So it makes it feels perfectly fine. If I switch to a right motion, you see how quickly you run out of motion, and so it has to kind of snap because it's trying to complete the motion of your finger. The bottom actually feels fairly natural, but it's a much shorter motion because the object's getting bigger. Now, there's an interesting thing that happens on the left. On the left side, it goes crazy on you because the motion is going backwards. The differential in that direction goes backwards. So what this is telling you is always think about which side of what object you're actually trying to move and track with your finger. And sometimes you have no object in your animation that does that. Put a little off-screen object that does it. Or there's a mode where you can turn off, you can say, don't give it an anchor and just tell it, swipe right is doing this, swipe left is doing this. But it's a little easier to work with an anchor and get the kind of behaviors you're looking for. So the next step is when you try to create a keyframe. in keyframes, you can have position keyframes, attribute keyframes, and cycle keyframes. There's actually a bunch more coming. One more I put into this mix is Keytime Cycles. Now, let's talk a little bit about the position keyframe. So if I have a motion that's just simply straight up and down, and I want to put a keyframe in that bends the motion. So in this case, I said key at halfway, that's key position 50. I want to go all the way in the X motion. So that means the X motion of this, the X coordinate motion of this transformation will be completed, will go to 100% complete halfway through. So what does it look like? You see it quickly goes to the right and then moves up in a straight line. So eventually you get to kind of understand where and how the keyframes will move. And we'll show you more examples, and hopefully that'll give you some sort of feedback into this. Now, one of the things you might also do here is you'll say in the Y. So here I've retarded it. So half of the motion is at the bottom, and then it shoots up. So the velocity actually is increasing in the second half of the animation. That brings up, you heard me talk about it in X and Y. So it brings up, we actually have 3 different coordinate systems and that you can choose to use with your keyframes. And keyframes are about getting a little bit more of a subtle motion. So first, let's get some basics. You have a widget on one side, it's going to move to another side. So that's the starting and that's the ending. Now, the first coordinate system is parent relative. It's essentially saying, ignore where it starts or ends, just let me describe the coordinates in terms of the parent, the motion layouts view. So that, and you'll see, and we'll have an example where you'll see why you would need this. The second one is delta relative, which is what I was just using, the default. It's actually the most practical. It's very useful for a lot of different animations you'll find. And the third is path relative, which is where we sort of rotate the coordinate frame and align it with the motion path. So the X in the coordinate system is the path of the system. 0 is the start, 1 is the end where it reaches. So the delta relative, here's a good example of why the default is so useful. In this case here, I'm simply setting, for all of these 9 views, I'm setting at halfway, I want to complete the X motion. And you can see it's your settings menu. It does that smooth animation. Also, I've added some fading of some views and things like that. But with just 2 layouts and this kind of keyframe, it works. So the next type is attributes, and those are any of the post layout attributes of a view, the default attributes on a view. So in this case here, I'm going to distort the motion with a rotation. Since the default rotation at the start is 0 and the default rotation at the end is 0, you can just simply put 1 in and have it twist. But it kind of looks ugly because it's going sideways. So we can add 2 attributes. So here I add 2 attributes. I rotate it back. It kind of has a nice natural motion to it. Here are a list of all the attributes. As you can see, it's all the scaling, translation, rotation, visibility. We have the ability to add a custom attribute, and that will do a reflection lookup of any property you want in the system. So the third one is cycles, and that's a little bit more esoteric, and you'll see a use case later. But essentially, it allows you to build very complex waveforms fairly simply and compactly. And when you get used to them, it's easy to understand what they will do. here's a few examples of just different cycles. Each one of these has 3 key cycles, a sort of starting, middle, and end. But you can see it's any kind of oscillation, bouncing, shaking, rocking motions. They're good at that kind of thing. So now we'll get into an example.
Yeah, and I would add for the cycles, what's nice is that, of course, you could do that with the keyframe position, but for this type of motion that can be specified as a cycle, it's much easier to specify a cycle than to have to painstakingly add a bunch of keyframes. So that's really to kind of help you with this type of work. So here is a basic example, and it's not anything that you automatically want to use in your application, but I think it's great to kind of explain some of the features we just described. So let's say that you have a basic animation where you want your son, to go over the horizon like that, and that is essentially doing the motion between the start constraint set and the end constraint set. That's not what a sun does, right? Typically, you want it to be higher in the sky. So, like the keyframe position would do that. And here we're using a specific type of keyframe position that use a motion arc. So we do support arc motion, which is very common in material design. But by simply adding this intermediate keyframe at 50 in the middle of the animation, we got this nice motion. So I may also want to change colors. And this is where motion layout is very different than purely doing animation on layout. Of course, we do animate positions and dimensions, but what you can do now is any type of attributes that essentially, as long as you have a setter-getter, we can animate it with, and we support multiple types. Here, I'm just using a color as essentially presenting itself as a drawable, which let me animate the background property of the view. So that's really helpful, because that means that your motion can just be encompassing not just the widget position, but a lot of those property changes that you otherwise would have to do in code. And here you can simply do it in XML. And here's an example of the Keytime cycle. So notice that the sun is actually oscillating. What's actually really nice is that even if I'm in the middle of the animation, the oscillation is actually continuously running. Otherwise, it would simply follow whatever path I specified with a cycle, but would stop when I'm stopping the animation, right? The gesture I'm doing is simply going at a specific point in time of the animation. So Keytime cycle is a variation on the key cycle concept and basically work in time. And so that really allows you to do this kind of much more interactive behaviors. I think it's pretty cool. So another aspect of motion layout is that we are not just manipulating drawables, right? We are actually manipulating views, and you can interact with views. So you can think about, motion layout not just as a way to create an animation, or not even just an animation that is touch-driven, but really as a way to interact with your actual user interface. It's not just drawables, right? So here is an example that it's going to look very much like a coordinator layout, but it's actually full motion layout. And again, it's completely declarative. So, and again, the examples are on GitHub, so please check it out. But the idea here is that we nest 2 motion layouts. One motion layout is going to take care of the overall behavior, the fact that if I'm scrolling up, the toolbar is going to resize, the fat button on the bottom right is going to show up. I can just specify that as 2 constraint set. And then we have a second motion layout that's going to basically drive the behavior of the collapsible toolbar. This is actually exactly the same example as the one I used in coordinator layout earlier in the talk. It's just here I'm using it in a motion layout. But what is really nice is that of course, I can replicate the coordinator layout behavior this way, but you are free to do anything you want. It's no harder to do something different than to replicate a coordinator layout. And I can simply do that by specifying the overall behavior at the start of the transition and at the end of the transition. So another good example of kind of coordinated layout is this one from our own Chris Baines. And I really like this one because if we look a little more into it, you'll see that there is a lot of things happening and a lot of things that happens that needs to be coordinated, right? The text is going to fade out. The poster is going to rotate and rotate in a specific way so that it match the cut into the window. So this is the type of things where motion layout is really, really good at, because you can very easily tweak those values until they match the behavior you want. And it's definitely, believe me, a lot easier to do that in XML declaratively than in code. So something that's coming in Alpha 3 is the support for multiple states. And we actually do support multiple states already in Alpha 2, but what's nice here is that we drive the transition between those different states purely with touch. So that's a pretty powerful feature as well. So as a summary of ConstraintLayout 2, so we got the helpers object, and now you can use them. You can create your own helpers, and I really encourage you to do that. We got virtual layouts like the linear layout and flexbox-like layout and table and things like that. And of course, motion layout. For just so you know, essentially ConstraintLayout 2 is right now about 300K, which is about twice the size of ConstraintLayout 1. So motion layout is not a small part of the code. It's a pretty complex behavior, and the goal for us is that all this work essentially will save you time, right? So we released it as an alpha release at Google I/O. We, right now we're at Alpha 2. We're working on Alpha 3, and even though it's an alpha, it's actually based in terms of the motion, in terms of the layout, computation, and etc. It's based on ConstraintLayout 1.1, so it's actually pretty stable. We use the alpha label as more as a way for us to make sure that if we do want to break the API or more likely add new APIs, we can do so. So that's kind of our cover. But in terms of stability of the code, it's pretty stable. So hopefully, we'll try to release it in a few weeks. I recently had a new addition to my family that is both very cute and demands a lot of time. So it might take a little longer, so bear with us, but it's coming. Okay, we have a ton of documentation that we put online. The Medium articles go into excruciating details, hopefully. But the nice thing is that it's a text resource, right? So you can take your time, do it, without a French accent. It's really cool. Try it. And of course, we got everything. All those examples I've shown you are on the GitHub that contains the constraint layout examples, and we basically added the motion layout examples.
So in Alpha 3, there are going to be a few changes to the XML. We're going to have a slightly different declaration of a constraint set based on feedback from people in the community. And when we do that, we'll also update the GitHub to reflect those changes. The old stuff will remain compatible, but we will be migrating to a slightly new format. And that's kind of the things that we're looking to do in the alphas. Try and sort of finish the API based on feedback. And in general, if any of you have any feedback about the XML, and in Alpha 3, you will also see some of the Java accesses to a lot of the internals. If anybody has any feedback about it, please contact us.
Yeah, and we are both John and I are very easy to contact, hopefully. So you can contact us on Twitter. We got also the Slack developers. We tend to be there and chat with people. So in general as well, if you have a problem, if you have questions, or a feature request in general, do file bugs. We actually, trust me on that, we do look at those bugs. And for us, it's really a way to track those features. But more importantly, and that's why I think it's in your interest to file those bugs, is that it gives us a way to communicate with you, possibly to ask more questions, but also so that you know when we fix something, you'll know about it. So that's a very useful tool, and please do file bugs or feature requests. And that's it for the talk. Thank you very much. We have some time for Q&A, I think. Okay, so the question is basically, this is all great, but what do you do for fragment transitions? And we have a couple of ideas. Not everything is fleshed out. As I said, it's an ongoing project. We are trying to, to improve it as we go along. But we actually have some examples in that GitHub that drive fragments and drive the fragments transition. Again, you can use MotionLayout in two ways, right? You can use it as, this is essentially just a custom view that lets you do animation, cool. But you can also use it as more like a view that will let you coordinate a bunch of other views, right? Their children. And one of those some of those children could very well be fragments, and you just drive So there's a couple of things we want to do to, in general, make that even easier. Right now it's possible, but you do need to do a little bit of code, and the hope is that we'll come up with an even nicer solution. But essentially, it's already doable.
Well, one of the things that you kind of touched on a little bit there that I feel we can build a lot of user interfaces simpler if we use MotionLayout. Instead of, if you look at like building a view pager, you can build a view pager with MotionLayout. And if you do it that way, it could be simpler. It may not be simpler. You have to decide on what you're doing and how you're doing it. But not only will it be simpler in many cases, but you can then put your own twist on it, your own little bits of flourishes about when you're moving, what to do. Maybe you put in a keyframe that makes them dip or shake or something like that. And you can do that all sort of like declaratively in a separate file. It's very easy to work with, and all your views are staying there in one space. You can find view by ID on all of them. They're all there permanently. And that's one of those nice things that makes it easier for simple usage.
Yeah, that's actually a very good point. Like one of the really nice thing is that when we apply those constraint sets, when we change the position of those widgets, we're not recreating those widgets. So you don't have an inflation cycle, you don't have to recreate things, you don't have to rebind things. Those are just the views you are using, we just move them somewhere else. And that, in many situations, simplify things a lot. I'd say also that we are thinking about ways of doing stuff more at runtime, where the idea is that MotionLayout would basically take care, or you'll be able to specify stuff that you then drive programmatically. But the idea is that instead of doing everything in code, you would only do in code kind of like the decision logic of what's animating or not. And again, more stuff coming. Performance metrics. Okay, so how does it compare with coordinator layout?
Yeah. It's hard to say. Most of the efforts in many of these animation systems is actually what you're trying to do to the views. Like having to paint the views, and if you're trying to do scales on images, you're blitzing a lot of images during the animation. Things like that can cost you way more than the basics of moving objects around on the screen. So in general, one of the things that I would even caution with coordinator layout, but MotionLayout definitely, before you get too carried away with what you can do on your fast, super fast phone, kind of pick your targets, make sure, and one of the things that I've done is there's a debug flag now that if you turn on, in Alpha 3, there's a debug flag. That will actually show you at the bottom frames per second you're getting during the animation, so that you can use that to sort of gauge, are you hitting your mark? Are you constantly at 60 frames per second? Because that actually, I've done lots of animations. Oh, look, I can play 10 images on the screen and animate and move them around, and then on a slower phone, it kind of like, okay, that's not working.
So I think in general, the performance is actually pretty good because the lower end the device, typically the screen resolution is also going to be smaller. So all in all, you end up okay. One big thing we saw that that could be a kind of a trap is if you are using really large images. If you have a very high-end device, it's going to all fit into your GPU memory and it's going to be perfectly fast to animate. On lower-end device, maybe those large images are not going to fit and suddenly things switch back to a different solution and that's slower. So essentially, it's perfectly doable to do fast animation and fast motion. You just need to be a little careful about what you are doing, but that, I think that makes sense as well. I think there was a question in the back first. So the question is snapping supported? So the gist of like the concept, I guess, is that we do specify states with constraint set, and with that you have all the power of constraint layout. And the idea, at least the way we think about those states, they are kind of resting states, you know. And right now, I don't think we do support quite the snapping, but that's something we are thinking of.
So if there's a specific interaction style you're looking for, but in general, the resting states are constraint sets. And if you saw that multi-transition where there's two, you could say, snap points where it's expanded a certain amount, expanded another amount. And so we're looking to do that kind of thing. But if there's more you're interested in, you know, use our Twitter handles and sort of describe what you're looking for or file a request for enhancement.
So yeah, typically like in Alpha 3, the multi-state transition will support that. But yeah, if you need more, just tell us. And I think there was the last question, maybe? Yes.
Yeah, let me...
So the question is essentially, you specify at the very least a start and end state. Great. How do you specify that? With multiple constraint layout files?
So there are two ways you can do things. You can do them as separate layout files. So 3 layout files. One is 2 constraint layout files and 1 motion layout file. And then have the constraint set. Instead of a constraint set, you point to the layout files in the motion scene file, which is the 3rd file. The constraint, or you can directly specify them within the motion scene file. There are different trade-offs between them. Generally, when I start, I do two layout files, but as I progress and I stabilize my layouts, I move them all into one constraint motion scene.
Yeah, and one little thing is that you can basically use the layout as your base state, a layout file, your layout XML file as your base state, and do the deltas, if you want, into the motion scene. And that's actually part of the new XML approach that we are doing in Alpha 3, is to give you more fine-grained way of overriding stuff. All right. Please come to see us afterward. Otherwise, thank you very much.
All right. Thanks.